Welcome back to Code Symphony, Unraveling the Code Mysteries. I am your host Burhanuddin, and today we are diving into one of the most debated topics in the world of database management: SQL versus NoSQL. It's a classic dilemma that every developer and database administrator faces at some point in their career. Let's start with SQL, or Structured Query Language, which has been the backbone of relational database for decades. SQL databases are all about structure. They use predefined schemas, meaning the data is stored and organized into tables with specific rows and columns. This structure is what gives SQL their strength in handling complex queries and ensuring data consistency. SQL databases are also known for adhering to ACID properties that are atomicity, consistency, isolation, and durability. This makes them reliable for transactions, especially in environments where data integrity is crucial. Some popular SQL databases you might be familiar with include MySQL, PostgreSQL, SQLite, and Microsoft SQL Server. Each of these databases has its own strengths, from MySQL's widespread use in web applications to PostgreSQL's advanced features and standard compliance. Now let's turn our attention to NoSQL, which stands for Not Only SQL. NoSQL databases emerged as a response to the limitations of traditional relational databases, particularly when it comes to handling large volume of unstructured or semi-structured data. One of the key advantages of NoSQL database is their schema-less design, which allows for greater flexibility. Unlike SQL databases, you don't need to define the structure of data in advance. This makes NoSQL ideal for situations where the data model might change over time. NoSQL databases also excel in horizontal scalability. Instead of scaling up by upgrading hardware, NoSQL databases scale out by adding more servers. This is particularly beneficial for big data applications and systems with high traffic. Popular NoSQL databases include MongoDB, which is document-oriented and highly scalable; Cassandra, known for its high availability and fault tolerance; Redis, an in-memory key value store often used for caching; and Neo4j, a graph database optimized for handling complex relationships. So how do you choose between SQL and NoSQL? It really depends on your project's specific need. If your data is highly structured and relational, SQL databases might be the best fit. On the other hand, if you are dealing with unstructured or semi-structured data, NoSQL offers the flexibility you need. Scalability is another consideration. For applications that require horizontal scalability and can handle large volumes of data, NoSQL is far better choice. However, if consistency and transaction integrity are your top priorities, SQL databases might be the way to go. Let's not forget the use cases. SQL databases are commonly used in financial systems, enterprise applications, and other environments where complex queries and data consistencies are crucial. NoSQL, on the other hand, shines in big data analytics, content management systems, and applications with dynamic data models. The choice between SQL and NoSQL is not one size fits for all decision. It requires a deep understanding of your project's requirement, the structure of your data, and your scalability needs. By carefully evaluating these factors, you can make an informed choice that aligns with your goals and ensure optimal performances. Thank you for tuning in to this episode of Code Symphony, Unraveling the Code Mysteries. I am Burhanuddin, and I hope this discussion will help you navigate the SQL versus NoSQL debate with confidence. Join me next time as we continue to unravel more coding mysteries.